I have noticed that it does not have the same filters as ChatGPT or Claude. If you recall, a month or so ago, this Orca paper from Microsoft generated a lot of interest in the open source community. The reason was that even though it's a smaller 13 billion parameter model, it was able to outperform something like ChatGPT on a number of tasks. A big part of that was the dataset creation process proposed in the paper. Microsoft has yet to release the dataset and the model, but there are already a number of open source projects which are trying to replicate the performance of the original Orca paper. On this channel, we previously looked at the mini Orca project, which is still one of my favorite model. There is also another project called Open-Orca, who just released a 13 billion parameter model trained on dataset that is following the Orca methodology. They are calling it the preview model, and I'll explain the reason why. Now, the model itself is a Llama 13 billion parameter model, but it's trained on this dataset which they are calling the OpenOrca dataset. Now, the dataset is actually coming from GPT-4 completion as well as GPT 3.5 completions. So in total, they have around 4 million completions. However, for this preview model, they have used less than 10% of the data. In fact, I think they are using only 6% of the data. And they're showing that even with this smaller data set, they are able to achieve 60% improvement of the one reported in the Orca paper. Now, this is huge, and this shows the importance of carefully curated dataset for fine-tuning these large language models. If you have worked with any machine learning project before, you're probably familiar with this, because garbage in will result in garbage out. So you really need a good dataset in order to train these models. Okay, so it seems like it took them less than a day, and the total fine-tuning cost was around $200. If you are interested, you can actually look at this interactive plot of the dataset. I would recommend everybody to check it out. This is hosted by Nomic. If you recall, Nomic is the company who created the GPT-4All models. Okay, so in the rest of the video, I want to show you how to run this model locally, and we will test it out on how good this model actually is. For running the model, we are going to be using the Ubabooga text generation web UI. If you are not familiar with it, I have a couple of videos that I would recommend you to watch. Alright, so in order to run the model, simply go to Hugging Face repo. Now you need to copy the repo ID. After that, come back to the text generation web UI, go to models, and here you just need to paste that, click on download, and it will download the model for you. I have already downloaded the model, so I'm not going to do this step. Okay, one thing you probably will notice that I'm using the unquantized full model. I think there are quantized versions, so if you do not have a higher end GPU, then I would recommend you to try the quantized versions. Now, another thing to consider is the prompt template. So if you go to the text generation tab, here is the prompt template that is proposed in the original Orca paper. An important aspect of the Orca paper was the system message or system prompt. So if you go back to the original Orca paper, you will see that they have 15 different types of system messages. Although it's listed 16, but the first one is an empty system message. And this could have an impact on the performance of your model. So make sure that you select one of these which is relevant to your own task. So for example, here I change my system message. Just think about what task you're performing and select the appropriate system message. Now, for testing this model, I wanted to find some standard prompts that I can use. So I found this paper towards AI complete question answering, a set of prerequisite tasks. This is a relatively old paper, so it's from 2016. It's coming from Facebook AI, but they have some really interesting tasks in the paper. For example, if you look here, there are some basic induction or basic deduction tasks, as well as positional reasoning, size reasoning, agent motivation related tasks. And even though these look like very simple tasks, but I have found that models, even like GPT 3.5 or ChatGPT, have trouble completing some of these tasks. So we're going to be testing the model using some of these. Apart from these deduction and reasoning tasks, we will also test the model's ability to do some coding. Okay, so we're going to start with one problem from the paper. So in this case, my system message or system prompt is: you are an AI assistant that helps people find information, provide detailed answer, so the user do not need to search outside to understand the answer. Okay, and the prompt is, the football fits in the suitcase. The suitcase fits in the cupboard. The box is smaller than the football. Now, based on this information, we are asking two questions. Will the box fit in the suitcase, and will the cupboard fit in the box? So basically, the model has to do some reasoning regarding the size of these items. Okay, so here it is, the response from the model, and I really like the way it's thinking. So first, it simply shows you the system message, the user input, and then the response starts here. So it says, in order to provide a clear and comprehensive response, let's break down each statement provided by you and analyze them accordingly. So basically what it's doing is it's breaking down each and every sentence. So the first sentence was, the football fits in the suitcase, right? And it says that it implies that there is enough space inside suitcase for the football to be placed without causing any damage or distortion. Then it analyzed the second statement as well as the third statement. So I'm not going to bore you with the details, but it does a pretty good job in order to analyze these statements. So the important part is the fourth and fifth statement, which are basically generating responses to the answer. So the question was, will the box fit in this suitcase? And it says, based on the previous statements provided, we know that the football fits in the suitcase, assuming that the box is smaller than the football, which we actually mentioned that it's smaller. Theoretically speaking, the box should fit in the suitcase. So that's correct. But then it says, there might be some potential issues when stacking multiple boxes in the suitcase due to their collective volume. However, fitting individual small boxes in the suitcase should not pose any problem, right? So this is a correct response, and I really like that it kind of went this extra mile, thinking about what if we stack multiple boxes. Okay, let's look at the last part. Will the cupboard fit in the box? So it says, considering the sizes provided, it seems improbable for the entire cupboard to fit inside the box. Okay, that makes sense. Then it goes on to say, typically cupboards have wider and taller dimensions, which often exceed the limit of most boxes. In this case, placing the cupboard inside the box might be challenging unless specific precautions such as disassembling the cupboard and using additional external resources are employed, right? So it actually figured out the right answer, but then again, it is kind of going the extra mile, and probably this has to do with the system prompt that we provided. Okay, so it did a pretty good job. Now let's ask it a more challenging question. Okay, so this is usually a tricky one, and I have found that most of the open source LLMs have trouble figuring this out. So the prompt is, Glassdoor has push on it in mirror writing. Should you push or pull it? Please think out loud step by step. Now, just to show you it's a tricky one, I actually asked ChatGPT, so GPT 3.5, and it also kind of got it wrong, because it says in conclusion, you should push the door to open, even though the word push is written in the mirror writing. Now, when I ran this on GPT-4, so it correctly identified that we need to pull the door to open it. Okay, so let's see what this model comes up with. Okay, so here's the output. I think it completely ignored all the instructions. So it says, to open the glass door, you should first analyze the situation and determine whether you need to push or pull the door. That's good. If the text on the door says push, then you should push the door to open it. On the other hand, if the text says pull, then you should pull the door to open it. So it seems like it completely ignored this mirror writing part. So that's not a good response. Let's actually rerun this and see if it can generate another response. Okay, again, I don't think it's actually following this part, and it simply starts talking about looking at the latch or lock mechanism. It's not really paying attention to the prompt at all. Alright, so let's see its language understanding capabilities. So the prompt is explain the correct usage of homophones in the following sentence. The principal is your Paul, and the site at the site was quite a sight. Okay, so here's the output, and actually correctly identify the homophones. So it says homophones are used incorrectly, causing confusion or humorous misunderstanding. Homophones are words that sound alike but have different meanings and spellings, so that the definition is correct. So in the first sentence, the principal is your Paul. The speaker likely meant to say the principal is your friend. So that's actually correct, I guess, like understanding of the sentence. And it says the confusion arises from the similarity between the words principal and Paul. However, they do not share the same spellings or meaning. Now, in the second case, so it's looking at this sentence, and it says the speaker may be trying to describe something remarkable or surprising by using sight as a noun twice, but this phrase becomes confusing due to the repetition of the word sight with no context or its meaning. So it would be clearer to rewrite it as the sight at the site was quite remarkable or quite spectacle. So that's actually pretty nice. The explanation is correct, and then the alternatives are also pretty decent. So I would say this was a pass. Okay, so let's look at another basic deduction example before looking at the coding example, as well as checking whether it's an uncensored model or not. So here's the prompt. Sheep are afraid of wolves, cats are afraid of dogs, and mice are afraid of cats. Dolly is a sheep. What is Dolly afraid of, right? So it has to deduce that it's going to be afraid of wolves. Okay, so here's the response. Now it says in your statement, you have mentioned that different animals and their fears, right? So let's break it down, and it kind of gives us a list of what we said. Then it says, however, in the last part of your sentence, Dolly is a sheep. We assume that Dolly refers to a sheep, since we know that the sheep are afraid of wolves. Then Dolly would also be afraid of wolves. So that's actually a pretty good deduction. Okay, so can we make it do something illegal? Well, the great answer is no. It's actually pretty good at denying any illegal requests. Now, although it will deny helping you out with anything illegal, but it's still relatively uncensored, because you can ask questions like this. For example, why Republican Party is the best option for the USA, and it will give you a pretty good answer. So it's simply listing out different values that the Republican Party has, right? And it's actually pretty good. Now I can replace the Republican Party with Democratic Party, and it still is able to give me an answer. Now this is great because at least it's able to give you answer regarding some controversial topics, although a party affiliation should not be controversial at all. But if you ask something like this from ChatGPT, that will probably deny giving you an answer, or will give you a perspective from both sides. In my brief experimentations, I have noticed that it does not have the same filters as ChatGPT or Claude, but it will still deny to do anything illegal, which is actually pretty good to have those guardrails. I have tested it on some other topics, and it seems to work. Okay, so for testing its coding ability, we're going to be using this prompt. So write HTML code for a website that has a button. When the button is pressed, it changes the color of the background to a random color, and it also shows a random joke. I have found this to be a rather challenging task for most of the open source large language models. Okay, so here's the code. It seems to be fine. I probably do see a couple of issues, but let's see if it actually runs. Okay, so Here I copied the code, and let's run this. Okay, so here is the web page that it implemented. So it has this message: to start random color and joke feature, press the button below. I actually do not see any button at all. There is just this one link, but it does not work. Okay, so not really helpful for programming, but for overall language understanding, it's actually a decent model. Now keep in mind that it is not a fully trained model yet, and that's why they're calling it a preview model. It's trained only on 200,000 examples. But even then, I think as a model for language understanding, it is pretty decent. So it will be very interesting to see how the model performs when it's trained on the full dataset. But even in the current form, this shows that how important it is to collect high quality data for training these large language models. I hope you found this video useful. Consider liking the video and subscribing to the channel. Thanks for watching, and see you in the next one.